Now here I've got a copy of the table that we're given in the question, the distance to the nearest mile travelled by the commuters. And in part A we're asked to describe the shape of the distribution. Well, you can see that many of the commuters travel somewhere between 0 and say about 39 miles. Most of the data is bunched up at this end. And that is a sign of positive skew. Let me just show you. If we had a little graph, okay, here, and this was the distance travelled, okay, and this was the number of commuters, then what we would have is in these lower end, from 0, okay, up through to 9, all the way up to 89 down there, you're going to find that you've got most of the people bunched up this end, and it's going to tail off like that. Okay, so when you've got the tail like this in the positive end, okay, like that, we call this positive skew. And that is the answer then to part A, positive skew. Now in part B, we're asked to find the median for this distribution. Now the median will be the middle value, and we've got to find out where the middle value would be. Well, first of all, we would need to add up this column here, the number of commuters, although we are told that it comes to 120. So we have 120 values down here. So the median would be the 60th value. And you can see that if you come down here, 10 and 19, if I was to add that, okay, 10 and 19 comes to 29. And if I add 10, 19 and 43, then what I get is 72 values. So clearly the median is going to lie in this interval 20 to 29. That's the 60th value, okay, in that interval, 20 to 29. Now, in order to find that, what I always do is I never use the formulas that you find quite often in textbooks. I just find them so awkward to use. So this is the method that I use. I just draw a number line, like so, and this number line is going to represent the class interval. The class interval that in this case goes from 20 to 29, okay? But remember, this is to the nearest mile, so the class interval really is, we've got to quote the lowest bound for this interval, which would be 19.5, and the upper bound would be 29.5. Now, you can see that we've got 29 values below the lower bound up to and equaling that lower bound, so I'm going to put 29 there, and we've got 72 values below the upper bound, which was the 29.5, so I'm going to put 72 there. And we've got to find out where the median lies in this interval, where the 60th value is. Now clearly that's going to be towards this end, so I'm going to look for the 60th value and call that Q2. Q2 is the normal symbol that we would use for calculating the median. Okay, so how am I going to do this? Well, I'm going to use proportions, okay? I'm going to compare this interval here with the total width of this interval, and I'm going to say that that is in exactly the same proportion as this interval compared with that interval there. And so as a sum, okay, all I've got to do then is just write that down, that this interval Q2 minus 19.5 compared with this interval, the red dotted line, that is 29.5 minus 19.5, is exactly the same as comparing these green intervals. So that will be the solid green interval, 60 minus 29, 60 minus 29, compared with the dotted green interval. That's 72 minus 29. 72 minus 29. So all I need to do is just simply rearrange this. Well, we've got Q2 minus 19.5, and if I subtract these two from one another, I get 10, and 60 take away 29 is 31, and 72 take away 29 is 43. So all I've got to do now is multiply both sides by 10. That will give me Q2 minus 19.5 equals 31 over 43 times 10, and then add the 19.5 to both sides to give me Q2 equals 31 over 43 times 10 plus the 19.5. And if I do that on the calculator, I find that I get 26.709 and so on, and that means that Q2 to three significant figures is estimated then at 26.7 to 3 SF. Alright? And that brings us to the end now of part A and B.